I'm Mark Roski. I run the collaboration effort at Quanterix, and I've been at Quanterix since near the start of the company. Many of you know me, and I'm really pleased to be here this evening with Professor Henrik Zetterberg, who kind of doesn't need an introduction, but I'll give a brief one anyway. He's the department head of psychiatry and neurochemistry at University of Gothenburg. And then he's also got many other appointments that it's hard to keep track of, although he's a professor of neurochemistry at University College London as well, where he runs the fluid biomarker group there. Henrik has over 1,000 publications in the neurodegeneration field. He's been responsible for a large variety of new assays. Our interactions at Quanterix started with Henrik about 10 years ago. And it's really an amazing situation where this small little company in Boston called Quanterix developed a new technology, Simoa, a single molecule array, and it enabled an ultrasensitive immunoassay. And we didn't really know what to do with ultrasensitive immunoassays. We developed 3 prototype assays, one for troponin for cardiac, one for PSA for oncology, and tau, a tau assay. And we thought because that might be relevant for traumatic brain injury. And we continue to collaborate. We're very excited we've just recently launched a brain-derived tau assay on Simoa through a collaboration with Henrik and his team in Gothenburg, and we continue to work on next-generation assays. So we're really excited about that, the future, and to kind of kick off the questioning, maybe I'll focus a little bit on tau, just because that was the first one we worked on. So.
But could I comment on what you just said?
Please, absolutely. That's the point.
My recollection of this is it's exactly like you said. And we didn't believe that this would work as well as it did. So what we said, okay, let's test something where we know there is massive brain injury. Then a researcher called Sten Rubertsson in Uppsala was doing systematic studies on people who had out-of-hospital cardiac arrest, were resuscitated on the way into the hospital and came to the emergency unit with circulation but unconscious. And then he systematically followed these patients with repeated blood samples, a lot of EEG measurements, clinical testing, and then he could group the people into good and bad outcome. And this total tau assay that you had developed distinguished these people with almost complete certainty at admission.
And so we've come some way from total tau to now, as you can see in this meeting today, everyone's talking about p-tau 217.
Yeah. I mean, tau is such a good example because tau, the assays we have had access to in cerebrospinal fluid have been total tau and one phosphoform of tau. And they work really well to detect Alzheimer's pathology. And then, but with tau, with all the isoforms, it's a much larger proteins, all the different phosphorylation sites. There is also glycosylation, there are truncations happening. We have, when starting out with the total tau assays, it became quite clear that if you measure very specific forms, sort of subforms of tau, then you could get information beyond what was possible with the total tau assays and also with the most standard phospho-tau assay. When you measure these subforms, you automatically lose a lot of molecules, of course, so the assays need to be very sensitive. And I think that is why you played such an important role in the early blood tau work, right, because it was not possible to do these measurements with other technologies. So the proof of concept studies and developing tests on Simoa for the different subforms, this opened up the field. What has become clear is that these different phospho-tau forms, they carry some information which distinguishes different stages of Alzheimer's disease. And you all know now that, I mean, it really looks like the new treatments against amyloid should be initiated at the stage where the tau pathology is not too severe. And it looks like 231 to 17, the phospho-tau forms, that they change a little bit differently during the disease process. And that the level of change, the magnitude of change also gives information on how advanced the disease is in the brain tissue. And there are research groups now who are trying to use these different phospho-tau forms to stage Alzheimer's disease from a biofluid. This has traditionally been done with tau PET, and I really think that is important. And we should continue to work with both tau PET and correlating the plasma biomarkers to that.
We really appreciate our collaboration. It's generated a lot of great research and moved the field forward, and we'd like to continue working with you. And thanks for coming. And
thank you for doing this and for keeping the homebrew assays going, because
Excellent.
that's amazing.
Excellent. Thanks. Thanks, everyone.